any question about yesterday's class or contents, we should drop to today's coding sessions. As we said yesterday, we provide information as we are needing it. We don't want to overflow it with information. The only thing that you have to know is that the idea for today is to do practice, right? It's the only way to learn to code is by doing a lot of coding, practicing. So that's everything you have to know. All the projects that we do are from the first minute meant to follow industry standards, right? So there are GitHub repositories. The way to deliver them will be through GitHub pull requests. You will run tests with test frameworks used by every major company out there. So everything is going to be industry ready, if you want. Of course, that the drawback from that is that sometimes it can be complicated to understand all the tools that we're using. But that's the idea of these, at least first or second coding session, right? To get into the minimum level that you guys need for you to start working yourselves. You know, if tomorrow you gotta build your own project, you can just use the testing tool by yourself. So I am going to now, Rosie, your turn. This thing is being recorded, so
don't say anything stupid.
It's your time to shine.
All right, let me share my screen properly. You should see Chrome.
Yeah, it's good.
Okay, good. Okay, so for this first project, we are actually going to lead by example. So we're going to create the fork of this GitHub repository that you see here. And we're going to set up a C9 workspace. And then we're basically going to go through it and show you, how you establish it, how you start your code, how you run tests to completion. Looking forward to, take us into this first third of tonight's session. And in the second session, the next one, we're going to have you guys try it. So the first thing I want to do is create a fork of this repository. And to do that, you hit the fork button.
What's a fork?
A fork is a copy of the repository that is still connected to the master repository, but it's basically your own little place to mess around. So I forked it here, and you can see in the top left that it's under my profile, and it still has a reference to its master there. So this is mine. To get the URL for this, you're going to hit the clone or download, the green button, and hit the little clipboard. Boop. Now we're going to go to C9. C9 is just cnon.io. I'm going to bring it here. I'm going to create a new workspace. You can name it whatever you want. This is really just for your reference. We'll do ITP first assignment. We're going to leave it public. And right here where it has your clone from Git, that's where we're going to paste in your repo link. And then you can select Python as your workspace template and create. Creating takes a few seconds. It's creating a container, a virtual environment, pretty much. Does anybody have questions about that while it's loading?
I was just signing in. I might have missed something. Just create a new workspace. Is that what you wanted us to do?
Yep, you fork the repo and create a new workspace. We're actually not going to have you guys do it right now, though. So this is more just kind of a higher level kind of follow along. And then in the second session, we'll have you guys actually do it. So don't worry too much about the details at the moment.
Okay.
It's just for you guys to start getting familiarized with these topics.
All right, and so you can see that all the files on the left side there in that sidebar on our screen that were in the repo are now in this project. It is completely copied to your Cloud9, and there's two folders that she's clicking on. There's tests and then and that's where we're going to work today. So this first project is it's going to be a group project. We're kind of just trying to familiarize you with the entire process of getting stuff from GitHub and then doing a project together and then testing to make sure it works and checking the error cases. So this particular project is called highest number cubed, and basically what it does is so if you read here, we want to find out the highest number cubed. In this case, maybe that's less than 12,000. If you were trying to do that in your head, it's kind of difficult because we don't really memorize numbers cubed. If you were doing it on a calculator, you probably have to plug in one number after the other until you finally find the one that's the highest one that's less than 12,000. However, we have programming here, and we can write a program to do this for us without all that brute force methodology to find it. So our goal is to create a function called highest number cubed, and then we're going to pass it a argument, which is the number, which is going to be the limit. We're going to find the highest number cubed that is less than that limit. All right. And so we're all going to do this one together. Please participate, and we're all going to just kind of chime in and talk about it together. So Rosie, if you'll click on main on yours in the thing, yeah. There's our empty function. Now, if you did the assignments, you'll see pass always, and you just delete the pass, and that's where you start coding. So with this one, we want to figure out what the highest number cubed is. So does anyone have any ideas where to start? We're just going to work on this one together. So if anybody has an idea of what to do, feel free to chime in, maybe. Or we can guide it. Nobody?
Maybe start by having a while loop that gets to the limit.
Yep. You got it.
So, guys, just to recap, when I hear it, like everyone is so quiet, it's like big fear. We are the projects. I'm going to share my screen in a second, Rosie. So I go back and forth to GitHub.
We could take the 1/3 power of the limit and then floor the resulting float into an integer.
So can you define the problem?
Yeah, exactly. So let's go a little bit slower. The first thing is that this is the way we're going to give you guys a group project. You know, we have 3 coding sessions per week, Tuesdays, Thursdays, and Saturdays. This is the way that we're going to provide you with the group project. These are the instructions you guys have to follow, all right? You will not be required to do that by yourself today, because the idea is that we're going to follow these step by step, so it's not that complicated. Because again, there are so many moving parts, so many tools, and we know that it's maybe too much for the first day, and it's maybe it's a waste of time for you to start Googling it. You know, we want you to provide everything as ready as possible. So first of all, this is the way we're going to deliver the projects to you. All right, this is what you will get. Usually projects will be in a pair programming style. You will be paired with someone else. It's not the case today either, because we want you to struggle with these things by yourself first. So once you are with your teammate, you will see, oh, sorry, I confused the project, but it's the same thing. It's also a GitHub repo. As you guys are reading these, the project will start making sense, and you will start seeing the requirements. And here, Joel, is what you were just asking. The project will be described in a human readable way throughout this description. This is the README of a GitHub project. If you guys ever create a new repository in your GitHub profile, if you include a readme.md file, this is what it's going to be read, right? readme.md. And this is the human readable description. The project consists of many files. All these files make some sense at some point. We are going to be slowly explaining you what they are for, right? Slowly, again, we don't want you to overflow you with information. The most important thing is that these projects are test driven. So that's what Jason was saying. We have also the tests directory, and here we have the tests that they are meant to, of course, test if the solution that we're providing is okay. So usually we have two important files. The first one is the tests. So this is built by us, and this is what we are expecting. And the second important file we have is where you guys have to actually write your code, which is usually in this main file right here. This might change. We're going to provide different structures, and these structures will start to make sense for you, I promise. As you guys get more familiarized with these things, it's going to make much more sense. So what happens here? This is the function you guys have to build for this particular project, but this is, of course, empty. These are the tests, and these tests are requiring this function to do a few tests, right? So for example, in this particular case, sure, we're going to make more sense of the requirements later, but basically, when I invoke this function with the number 30, I am expecting the output to be 3. We are going to also start reading slowly tests. So that's also an objective of this course, for you guys to get familiarized with things that are not easily taught anywhere else. You know, it's like you cannot just get a book to 200 pages of test-driven development. That doesn't work. You have to slowly learn it. You have to slowly start making sense out of it. All right. So that's why we're going to take these small steps. So to recap, all the group project is going to be sitting in one repo. You will have to create your own fork. What Rosie did, that's recorded. You guys can watch it later. We're going to do it over and over again, so don't worry too much about it. You will create your own copy, but by forking it, and basically all the requirements are here. We then chose Cloud9 because, again, these projects will be meant for you guys to work in a group with someone else. So that's the way we have to collaborate with these in an easy way with a team, right? Working on Cloud9. Make sense? Any question before we jump into the real project? Cool. So what we're going to do, we're going to work on 2 projects today. The first one is going to be done by all of us together. And I ask you not to request access because the idea is that we don't want to plug Cloud9 again. So I, Jason, Rosie, we're going to be coding and you guys will be dropping ideas. And then what we're going to do is that we're going to give you other projects during this same session. You will just mute yourself and work on it slowly. We're going to do a step-by-step guide so you guys can start working on it slowly, all right? So I'm going to jump straight into the project now, all right? Any questions before that?
I just wanted to reiterate the explanation. So we know that 3 cubed is 27, and on that example, we plugged in 30 for the limit. And so we know that 3 cubed as 27 is the highest number cubed under that. And so we're just trying to get the number 3 there. It's kind of how that works. And 1 cubed is 1. So if we put 3 as the limit, then we're going to get 1 back. So it kind of looks like that.
Once I looked at that,
yeah.
So let's start even before that. We know that cube, it's a power, right? And to do, guys, someone is chatting. This is kind of distracting. I'm sorry. Briggs, can you just ask me? Unmute yourself and ask me. This pass thing, it's a good question actually, because we never explained it. In Python, I'm talking about the pass keyword. In Python, everything is defined by indentation, right? We have if something, a level of indentation, and then we keep working here. If we don't have like opening and closing brackets, so we need to respect indentation. What happens if you want to provide an empty function, right? Because you don't know what to put yet, right? It's empty. You know that you will need that function, but you don't know what to put. You need to put the pass keyword so the indentation doesn't break. Because if you keep your own code here, something more, more lines, it's like Python is reading this and it doesn't know where it ends. So the way to create an empty block, either function, if statement, or anything, is just with the word pass. So you can tell Python, look, this is empty right now. I might provide some values later, but right now it's empty, just keep going. So I was saying, before we get into that, the cube of a number, we have cube is a power, right? So we know how to square a number. Did we do that already? I think yesterday Jason explained it. So we have, for example, 2 squared, right? We can do 2 cubed, and that's basically the power of 3, which is basically the same thing as doing 2 times 2 times 2, all right? When we think about these assignments, it's hard not to get into the really mathy topics, because these mathy topics are usually simple enough to explain. But if you guys don't understand something, just ask it. So the idea of this assignment, and I want you to pay some attention here, is that we need to we will be given a number. For example, the number 14. This is our limit. And we have to find the largest number that that number cubed doesn't exceed this number. All right, so actually let's go back with the 30, because we have that example right there. So what is going to happen? We're going to start, for example, with number 1. We're going to say 1 cubed. And I can actually also kick off the Python interpreter so you guys can see it. I'm going to create a new one so you guys can see it in action. So what's the result of 1 cubed?
1.
1, exactly. Is 1 greater than 30? Of course not. So we can then move one number forward, right? When we can increment this number. So we can do 2 cubed. What is the result of that operation?
8.
8, exactly. So we say again, is 8 greater than 30? It's not. So we can keep going forward. We can do 3 cubed. What's the result of that? Python can help. 27. Is 27 greater than this limit? It's not. So we keep moving forward and we do 4 cubed. And now the result, 4 cubed,
64.
is 64, exactly. So 64 is greater than 30. So the number which cubes result is less or equal, Jason? Or it's just less? I don't remember if we have a test for it.
Oh, it's less than.
Less than. If the number that has its cube result is less than that limit, is 3. We will be just computing the power until we find one that exceeds this number, and the result will be the number previously computed.
I meant less than or equal to. My bad.
I don't think we have a test for that, so I don't think it's going to break, right? So make sense, guys, the requirement?
Yeah.
Yep.
Mhm.
Chase and Rosie, do you guys have any input? So we can...
So if you're looking at this problem and you're staring at it saying, where the heck do I start? What I generally do is I look for patterns. As you can see, we are consistently changing the number that we're cubing, and we're adding 1 to it, and then we cube it and we check it, and then we add another number to it and we cube it and we check it until the limit fails. And so seeing that, we can see some form of repetition going on. So maybe we can use some of our fancy control flow to get started. That's kind of what
Yep. So again, what Jason says, it's really important. As we were reading this, it's like the human explanation of it makes a lot of sense with a few like constructions we have. When I say I get a number, if I check if this number is greater than this one, I'm of course getting an if statement there. If the result is not, I keep going. That means that I will also have a for loop. So it's really important to start thinking about these human concepts and also put them or how they are translated into control flow structures, right? All right, so let's take a stab at it. The first thing we're going to do is we need a way for us to check if our solution is right, is correct. So how are we going to test that our solution is correct?
Run tests.
Yeah, exactly. So we need to run our tests. We're going to show you really, really quickly. We are not going to provide much explanations. We just want you guys to trust us that this is the right way, at least for the first coding session. As you guys are using these things, they're going to make more sense and you will start understanding why we need them. All right. So even for the second assignment that we're going to do today, it's also the same thing. We're going to tell you what to do. You just have to trust us, and everything is going to make more sense later. So what I want to do, I will provide some solution here. My solution, right? I will do something like for number in blah, blah, blah. I will provide some solution, and I want to know if this solution is correct. The way to do that is compare it with the test that I have written. I know that highest cube number of 30 should be 3. I know the highest number cubed of 12 is 2, right? So I need a way to run these tests and compare them with my solution right here, all right? I'm going to do it really quickly. And again, I don't want to get like too caught up on this because we're going to do it a lot throughout the entire course and it's going to make more sense later. The first thing that I'm going to do is create a virtual environment. Maybe some of you have already read about virtual environments. I'm going to give it a nice name. The second thing that I'm going to do is install dependencies or tools that we're going to use. As software developers, we will be using a lot of tools from other people, all right? We never write our entire software from scratch. We use tools, we use libraries written by someone else, all right? So I'm going to start installing the requirements or the dependencies for this project. And you can see how everything is going to be installed right here. The next step is, as everything is installed, I can just run this test. How do I run this test? We provide with a nice command that it's just make test. This make thing is related to this make file that you guys can all Google all this alone. It's pretty fine. It's simple to understand later. Right now, we're just going to use it. So now I'm going to run the test. I'm just going to do make test. And as you guys see, I have 3 fail or 4 failing tests. And that's of course expected because my solution right here is empty. I'm going to cheat. I'm going to go ahead and return the number 3. I see these tests and I say, let's just cheat and make one of these tests pass. I'm going to do something like return the number 3. So when these tests for this solution, the highest number cubed function will return a 3, and this test will be like cheated on. All right. Of course, these other tests will not like the 3 will not the right answer, so they're going to fail. But let's just do it so we can see what's our output right here. So I'm going to do make test, and as you guys can see, I have 3 failed tests and I have 1 passed. Of course, the 1 passed is this one because I actually cheated. But then if you guys see the output, it says like 3 is different than 2. In this case, it says test 2 is this test right here. It says when it's comparing the result of the function with the number 2, is of course realizing that the 3 is different than the 2, and it's in that case failing. If I provide the correct answer here through some control flow magic, all these tests should pass.
So is this comparing the 2 numbers with like a double equal sign?
Exactly. It's the same thing. It's actually, yeah, good point, and I can actually make a better semantic explanation. So we are going to have result is going to be the execution of the function, and then we're expecting a value. We're expecting a value 22. So these tests are basically saying something like, if the result of the function is not the same thing as the expected value, let's just expect it. Fail it. This fail is of course internal from this unit test thing. But usual, it's basically that process. It will just get one value, this one right here, the actually tested value, and a value that it's expected, and it will just compare them both. If they're different, then you have an issue with your test. You're expecting here 22, and this thing is returning 3. You are having an issue, right? So this is the way we will have to test. This test will get more complex as we're moving forward. We will have even easier ways to test. We're going to talk about the assert statement, other things during the next class. But this is basically the semantic behind it. I am upfront. This is test-driven development. I'm writing how my code should behave before I even write a single line of code. All right? I am thinking about how the program should work before I start writing the program.
So on a few of those assignments that you gave us,
yep,
you had some numbers that needed to be divided, and that resulted in a float value.
Yep.
And when you get a float value, it's, you showed us yesterday that, when you get out far enough, there might be some number at the end that's added, or it's not exactly equal to an integer.
Yep.
So how do you deal with that in a function where it'll test correctly? Where do you obviously you have to make it into an integer somewhere. Where along the process do you make it into an integer?
Do you mean for the test, or just a general question about for it to work for the test, in our examples, but I guess, in just, is there like a practice or a standard that... So everything starts with the domain of the problem that you're trying to solve. For some for some applications, this number right here might be the same thing as 3, well, in this case, let's see if we can have something like, no, I don't know how to get, for example, something like 3.000000004, right? For some applications, this value can be the same thing as 3. So if I tell you, I have a running application, I have Strava or Runtastic, and I tell you, Shoal, today you run 3 kilometers, but actually you had run 3.000000004. Will you be mad at me? You probably not. It's the same thing. There is no much of a deal. But if you're a bank and you're computing money and you perform trillions of operations per year, with this minimum error, you're already losing money, right? So it's important to understand first what's the domain of it. There are ways to test this. So for example, there is other type of test. Instead of being self-assert equal, is self.assert almost equal. The name is pretty good, right? Almost equal. That basically you can say how many decimal points you consider it not to be equal, right? It's like, look, I am expecting these two things to be equal up to some minimal error level. So for example, this is not equal to 3, but it is equal to 3. I am considering some minimum error. The question about when to turn it into an integer, never. If you're working with floats, why would you run them, right? Maybe if you want to display something and you have these and you want to display to the user, you run 3 kilometers, maybe it's better to just show you run 3 kilometers and not run 3.0004. But that's something that is going to be displayed for human friendly. So here's the answer to the second question. Is there a good practice? Yes, usually we try to write our messages for our users in a more friendly way, and we can accept some rounding there. Of course, it depends on the application, but usually it's like the last shell of your code. It's like you're interacting with a database, you have some internal processing. The last shell of it, or the last layer of your software, will be the one interfacing with the user, right? It's showing results and all that. And that point, it's a good thing to maybe round things to make them prettier. Make sense?
Yep.
So guys, tests. You already understood the problem, right? Where are all our examples? 1 second. There you go. We had, this is the problem we have to solve, and this is the function that will solve that issue, right? That problem. The way to test if our solution passed is by running these tests. I showed you really quickly, I don't expect you to remember how to run those tests, but basically it's make test. Well,
You gotta fix your test file. You got all the other stuff still in there.
Oh, thanks.
And this is an alternative to printing out your results. If you make your tests ahead of time, then you don't need to use the print statement. You can actually return values and then just run make test on them.
Yep. Yeah, exactly. Good point. Usually when you guys are writing software, it's like your prompt to do something like, I am expecting this result to be 20. I will print the result and I will see with my own eyes if it's 20. In this way, you have the computer checking things for you, so you can automate this. That's a good thing. All right. Any questions about the problem or how to run tests on all these crazy things you are doing? Nope. All right. Is there anyone lost? Okay.
Yeah, I'm lost a little bit, but it's kind of my fault.
Where?
Well, I understand the process here, but it's in general.
The process what? Sorry.
Sorry, I'm at a coffee shop. I understand the general process that's going on here, but I had to miss half of yesterday's class, so I understand, but I don't understand. It's kind of weird.
So we are not doing anything related to yesterday's class. The only thing that we are doing is we are defining a function and we are testing that function right here. We have a simple problem to implement or to solve by providing our own implementation, but that is basically all. There is, to be honest, there is nothing much to understand, right? It's like just we are defining.
I get what's going on here. I just answering.
Yep. So
I think, that if you don't have anything like specific you're tied up on, just kind of like watch as we go through it. And then the next exercise, you're going to kind of get hands-on. Yep. This is all a lot of information all at once. And I think that maybe you might just be getting a little bit overwhelmed with all of the different steps that you have to do. But I think once you get in there and like you see how we do it and you do it a couple times, it'll kind of come to you. So don't worry about it too much.
Gotcha.
Yeah, Rosie.
There's a lot of handling today.
All right, so how do we solve this problem? Again, we have a limit, right? We say, what's the maximum number that I can find, or the the largest number that I can find, which its cubed result is not exceeding that limit. So if I get the number 1, I cube the number, and I check the result, and I say, is this result greater than this limit? As it's not, I keep incrementing the number. I now have the number 2, compute the cube, and I get the number 8. Is this 8 greater than the limit? It is not, so I keep moving forward until I find that the number 4 is greater, the number 4 cubed is greater, 64 is greater than 30, and that's where I get my answer. The previous number, not this one, because this already exceeded my limit, the previous one, the 3, was the correct answer. All right? Make sense? Can you guys unhighlight this code? All right, thank you. All right, so how are we going to start approaching this? Anyone has a good idea? Or Jason, do you guys want to do it?
Maybe a while loop that checks, it takes in the limit, right, and then has either a variable or something that says, as long as this variable is under the limit, keep running. Once it reaches the limit or goes over the limit, it'll stop. And
yep. I will start providing a solution by myself without using for loops. So for you guys to understand why we need for loops, I'm going to do something like 1 equals 1. And I'm going to say 1 cubed. And I'm going to say 1 cubed is 1 times 3. If 1 cubed is greater than limit, I have found that this number is greater than this limit, then I will start with the number. I cannot do anything here, I'm sorry. But I keep moving forward because of course there will be, the number 1 will never be passed. So I will increment now the number 2, right? So I'm going to say 2. I'm going to say 2 cubed is going to be 2 to the power 3. And I'm going to say now, if 2 cubed is greater than the limit, what should I return now?
You should return 1.
I should return 1, exactly. The previous one used, this one, return 1. So now I keep moving forward, right? I'm pretty much following these examples right here. So the third example is the number 3. No, sorry, 3 first. 3 cubed. Sorry. I'm going to say something like, if 3 cubed is greater than the limit, what should I return now?
2.
2, exactly. I'm returning the previous one. And I will keep moving forward, just one more, 4 equals 4. 4 cubed equals 4 cubed. If 4 cubed is greater than the limit, return the previous one, which is 3. And I will just stop there. All right, so I have my function, which it will work for the first 4 numbers, or actually 3 numbers cubed. If I provide a value that it's less than 64, it should work. Because these solutions are all covering that. So let's run our tests again and see how many of these tests are passing. If I do make test, I have again my code here, sorry. If I do this will not break. Guys, when you highlight the code, please unhighlight it. All the tests passed except from this one. I'm actually going to remove this test so you guys can see that all these tests are passing. I have completely solved the solution for this. Nick, can you highlight this code? Nick? Guys, can someone ping Nick? So do you guys follow me? Do you understand what I do?
Yes.
What I did?
Yes.
Is there anyone that didn't understand it? I am just basically following this example alone. Of course, this is not something that we're going to, that it's going to scale, because as soon as I add a bigger test, this thing will not work, right? So I need to have a more scalable way. I need it to work for every number out there. And of course, I can't be typing 2,000 lines with, I don't know how many numbers. I need a scalable solution. When you guys start seeing that something is repeated over and over and over and over again, right? Like right here, this is a good fit for a for loop. All right, so I will try to turn this thing into a for loop really quickly. Basically, we know what is going to be repeated. I create a number, I compute the power, I compute the power of 3, I check it with the number, and if the result is greater than the limit, I just return the previous one computed.
Shouldn't you use a while loop because you don't know how big the number is going to be?
Yep, that's a good approach to it.
So pretty much you showing the if function here is just as an example of what not to do in this case, right?
The repetition, yeah, of course, this is an example of what I keep getting people chatting. This is a good example of what not to do in terms of repetition, of course, but it's also valid. You know, it's the idea of it's fine to do this. I mean, making sense of it out of a problem by writing it a few times and understanding that the repetition is needed. So let's start with a solution. The things that I need always a number to compute the power. All right. So I will have something like, I don't know, current number to compute the power. I don't know what it's going to be yet. I also need the previous number. I know that this case will never happen, so I can have something like previous equals 1 and current number equals 2. So I have the first two. This is my base case, right? From why I'm starting, the point from where I'm starting are going to be these two numbers. From now on, I could do something like, let me see if I added the test. Yes. I can do something like, sorry, the third thing that I need a previous one. I need one number, sorry, this number, and I need the cubed. So I'm going to do result cubed, which is basically current number to the power of 3. So now I have everything that I need, and I can do something like while result cubed. I don't know what it's going to be easier to read for you guys. Actually, I will do something like while true. I will start repeating. I will just start repeating forever and ever. This is dangerous because I can get into an infinite loop, but it's something that I can do. Guys, please stop me if you don't understand this. So what I'm going to do is I'm going to kick off the while loop, and I will just keep repeating, and I will repeat until I find that the result cubed is of course greater than the limit. So I'm going to do something like, if result cubed is greater than the limit, I will return something. What will I return?
Previous.
What?
Previous.
Previous, exactly. Previous. If that's not the case, if the result cube is still less or equals than the limit, I will, of course, keep looping. But what should I do so I don't get into an infinite loop?
Break?
But if I break, I'm out of the loop. I just computed once.
I guess you would like
previous and current number.
Yep, exactly. So we were doing one cubed. If this condition was not met, now we had two cubed. If this condition was not met, I had three cubed. So what I'm going to do is just swap the value. So now the previous number is going to be the current one, right? It's like I'm moving from here to here and from here to here. The current number, now it's going to be incremented by 1. So I had 1 and 2, then I'm going to have 2 and 3, then I'm going to have 3 and 4, 4 and 5. If 5 gets bigger than the limit, then I'm going to return the previous one, 4. Right? So I will start with previous in 1, current number in 2. Previous in 1, current number in 2. If the result of result cubed, in this case 2 to the power 3, is greater than the limit, I will return the previous one. If that's not the case, I move everything, so I have previous and current. Right? If this number is not greater than the limit, I just move everything back, and now the previous one, sorry, the current number becomes the previous. I assign this one and I increment the current number.
Shouldn't we like move result cube inside the loop?
What? Sorry, I didn't understand it.
Shouldn't we move that line 13 result cube inside the loop.
Yep. This one?
Yeah.
Yeah, exactly. What I was going to do is I was actually going to do the whole thing again right here to make it more readable. But yes, if we move it at the top of the for of the while loop, it's going to be the same thing. So it's the same thing, but it's the same process over and over and over and over again. We are getting a number, computing its cube number. If that exceeds the limit, we will do something. Get a number, compute the cube number. If the result exceeds the limit, I return the previous one. If that's not the case, I get a new number, I compute the cubed. If it's greater than the limit, I return the previous one. So I start with an infinite loop. If the result is greater than the limit, I return the previous one. If that's not the case, I just increment everything, I compute it again, and everything goes back to the start again, and we start all over again. Make sense? No? Yes?
It's okay to say no.
So I am going to run all the tests again, and I hope it works because I might be having an issue somewhere. And there you go. It works even for this big number.
Did you just essentially comment out all your code by putting quotes around it?
Oh, yes. Yes. Thank you.
For block comment, yeah.
Yeah.
That is a wonderful idea and much easier than hashing every line.
Usually some good editors have a simple command shortcut, a keyboard shortcut, so you can comment all your lines, but it doesn't work here. It has something. You can comment all the lines. It doesn't work. Yeah.
I think
That works.
Works for you?
Yeah, I'm on a Mac, Control /.
It doesn't work for me.
Well, it doesn't like you.
There's definitely
Yeah,
shortcutting.
aren't you on a Mac? It's command / on a Mac.
It's a Chrome thing, I think. I had some weird problems, and it said you have to install the Chrome app for keyboard shortcuts to work.
Oh.
Might be that case. This is not actually commenting out, Tracy. It's a cheat that we do on Python. It's just turning all this thing into a big string. So it doesn't have a real effect in your code, but it's not the same thing as commenting it out. Because when you comment out some piece of code, for example, let's start looping. When you comment something out, this will probably get removed by the interpreter. You know, it's like this just for humans to read. The interpreter, when it's turning things into byte, it will, of course, just don't use it. But this, in the other hand, this is a real string, so it's not the same thing. It has maybe the same result. It will not affect your code, but it's not the same thing. All right.
All right, thank you.
You're welcome. Questions? Rosie, Jason, something that I have forgotten maybe?
I just wanted to add something real quick. Probably a lot of you haven't seen while true before there. And like Santiago was saying, it creates an infinite loop. And the only way you're going to get out of that is if you either return out of the loop or if you break out of the loop. So you have to make sure you have conditions that will give you a way to exit that loop. Otherwise, you're just going to keep going.
So why would you do this versus just putting the while loop saying while the result underscore cubed is greater than
No reason. I just thought it might be easier to start reasoning. Like I will just start looping until I find something and break out of it, but it's a completely valid condition what you said, and I can actually do it. So what Lazar is saying is like we can and also Jason, it's two things important. When you guys start thinking about a while loop, the first thing you should think about is the condition that will break you out. Even if you even before you run the first line of code, think about what is going to get you out of that loop. In this case, what is going to get you out of this loop is the moment that you find that this result cubed is greater than this one. And that's what Lazarus just said. So I could have something just like result cubed, while result cubed is less or equals than the limit. I will keep trying to find numbers. So result cube of 1 is 1. 1 is less or equal than 30. I will keep iterating until I find one of these that is not less or equal, and that will drop me out of the loop. So I will, now as you guys can see, I have this condition and this condition. They are the same thing but inverted. This less than equal and this is greater than. I can take this thing out. I can put this, sorry, no, should we have it already down here? And finally, I can just return the previous number. Make sense? Will this thing work? Let me check if it works first. Yep, it works. Make sense?
Yes.
Any question? I have one more tiny improvement to do it. I don't know if anyone can realize it.
I have a question.
Yep.
So even if we don't specify the equation for the result cubed inside the loop, it will go out of the loop and check for it?
It's right here.
I mean, if we don't keep it here inside the loop.
No, you need to keep it. You will, if you don't have this thing here, you're going to have an infinite loop.
So why do you have 2 times? Like,
because I need.
Oh, it's up on the top too there.
Yeah, outside the loop and inside the loop.
Yeah, because I need something to start kicking off my my conditional, and then when I change it, I needed of course when I change the current number, I need to get again the new result. So if I had 1 to the power of 3, it was 1. If I have now 2, I have to compute this to keep going.
Okay. Okay.
He has it above it, but the first time it runs, it doesn't know what result cubed is. Yep. So he has to define it for the first time.
Yeah, like this will call it, like if you didn't have that line in there, it calls that variable assignment error, right? That.
Yeah, exactly.
Basically, you could make this 0. Like you could take result cubed and make it equal anything, and that's good enough to get the loop started.
Yep. I still have some repetitions. So I could easily, instead of having result cubed created in a variable and in a variable, I can have it just computed in place. So I could do something like, let's take this thing out, put it right here, remove it from everywhere, and that's it. I'm going to go back to where it was, and I'm just comment it out so you guys can see where it was before. So I'm going to run my test again to see if it works. And there we go, it works. Everything is green and passes. Make sense? Instead of, there are things that we don't need to store. We can just put them in place. You know, like this thing right here. I'm going to just put some parentheses so it looks better. But we don't need to store it. Just compute it, whatever you need it, and that's fine. Guys, questions?
No.
All right, so let's do something. Jason, Rosie, something to add before we stop for a few minutes before the next lab?
It's looking good. Yeah.
Cool. So guys, let's take 15 minutes because I want you to take a look at these again. You have Rosie's workspace, you have read-only mode, you can read these and take some time, and then we're going to get back here, and you are going to be the ones forking, cloning the works, creating the workspace and running the code and writing the actual code. All right, so 15 minutes, we're going to ping you through Slack. Please make sure that you are logged in into GitHub and Cloud9. All right?
And don't worry, because we'll be here.
Yeah, Rosie holds your hand.
How long is the remainder of the coding session? Like an hour?
2 hours. All right, go. See you.